Today I'd like to show you one of my favorite reactions. That's metallic sodium in water. Now, if you notice on the side of this container, it says the chemical safety guide has 3s for everything that's here. That means a 3 for health, flammability, reactivity, combustion, and whatever this last one is, I can't even read it. Storage. It doesn't store very well. That's on a scale of 1 to 3, 0 to 3. So this stuff is not exactly a safe product. And I'd like to show it to you. It's stored in oil because sodium reacts with water, which is the best part about it. So it comes in these lumps. Now sodium, when it's pure, is a shiny silver metal. But in this thing, it's kind of whitish. And that's because it's reacted with some of the oils that it's stored in. But if we look at it a little more closely and slice it open, we can see that it really is a shiny silver metal. So I'll put this back in the container. And I'm going to take a couple smaller pieces from this chunk of sodium metal, which is definitely shiny and silver. And it conducts electricity. It's a for real, honest to goodness, genuine metal. But it cuts with a knife. It's about the same consistency as cold butter. So there we've got 2 nice chunks. And to show how it reacts, I'm going to put this aside for a minute and get 2 petri dishes with water. So these are just glass petri dishes, and they've got nothing in them yet, but here's a little bit of water. Now in one of these petri dishes, I'm going to put a drop, just maybe 1 or 2 drops, of another one of my favorite chemicals, which is phenolphthalein. That is a word. Phenol, and it's PHTH, so phenolphthalein, and it reacts not with water, we'll put 2 drops in, but it reacts with a base, and you'll be able to see what that looks like in a second. So when you put sodium, which is a metal, right, into, this is just water, into just pure water, which is a pure compound, H2O, you'll see it skitters around. And the fumes coming out of that are really nasty. I don't know if you heard me choking on it, but definitely not something you want around you. So the reaction that's going on, it actually messed up my other pieces. Makes that piece of sodium disappear. And of course it's not disappearing. It's reacting with water to form a base. All right, now I don't know if you noticed that turned a little pink. So let me take a fresh petri dish, and I'm going to get this in the center of everything, and put my couple of drops of phenolphthalein in there. Because I contaminated the last one, I can't believe it. So here's my piece of sodium metal now. So you can see it's making the phenolphthalein react. So we've got a couple chemical reactions going on. The first is the reaction of the sodium with the pure compound water, and it's making sodium hydroxide. The second reaction is the sodium hydroxide reacting with the phenolphthalein, making it turn pink. And I'm going to take a small piece of sodium metal and drop it in. you can see something is happening. Now that smoke is very nasty. You don't want to get that in your lungs if you can help it. And there's no doubt that a reaction is taking place. And you might say that the sodium is disappearing, or you might not, because you know nothing is created or destroyed in a chemical reaction, but it's definitely changing. So what's happening is the sodium is reacting with the water molecules. There aren't a lot of things that react with water molecules like this, but sodium's one of them. And it looks like it's just disappearing, but it's in there. Now if we put a drop of phenolphthalein in, oh, there's some left over. You can see the phenolphthalein is reacting with whatever was in there. And that's one of the byproducts of the reaction of the sodium and the water. And it's a beautiful fuchsia pink color. You can see that it's definitely the sodium that's causing the reaction and causing the color change.